One of the things that's kind of been talked about briefly today, but then also a little bit in the conversations that I've personally had as well, is kind of where as we talk about the future, where physical AI and robotics has a part to play within our ecosystem. And so I want to bring up Doron Ariel Spitzer, Managing Director at E.ON. I killed you, I know. He's going to be joining us on stage, and followed by a pre-recorded conversation from our friends in Europe.
Good morning, everyone. Great to be here again, and actually a privilege to be back at the Energy Tech Week. Before I start, a huge shout out to the Ignite the Spark team, Sean, Aya, Cody, Eshel, and the rest of the team that I most likely forgot, all the Sparks teams. I believe that you are the glue to this industry, and I'm proud to have been one of your first supporters from the get-go. Your good energy and organization make this ecosystem flourish. At E.ON, our commitment to this community goes far beyond sponsorship. We are here to actively build the infrastructure of the future alongside the innovators in this room. For those less familiar with us, E.ON is the largest European electric utility, a 50 billion euro public German company, 80,000 employees, and we serve around 50 million paying subscribers across 16 countries. As a distribution and transmission utility, we operate the largest privately held grid in Europe, over 1.5 million kilometers of grid lines, which we are constantly optimizing, expanding, and securing. We also operate one of the largest district heating and gas networks and more than 700 charging points. We know that for an energy startup, the road from a brilliant idea to the global solution is complex. We bridge that gap. E.ON acts as a startup-friendly gateway, offering Israeli companies a direct path to the European market through high-impact pilots and deep-level design partnerships. Our goal is to move beyond the whiteboard and get your technology into real-world networks where it can truly scale. We do invest, but only after a successful pilot with a relevant business unit. If you are a pilot-ready startup, I urge you to apply to our flagship Open Innovation Program. It's called Free Electrons. You have the link on the slide. We co-founded this program about 10 years ago, and today 7 global utilities work together to explore partnerships with the best startups in the world. We look at nearly 1,000 applicants each year, which apply around October, and the deadline is towards the end of January. Please follow the campaigns and the webinars that we run with Ignite the Spark, and again, find out more in this website. And finally, I cannot step down without mentioning AI. It became clear today that AI hunger for compute is infinite, and the new trending currency is energy. E.ON is not just a massive AI consumer with our IT systems. We are actively helping data centers integrate into our footprint, whether through grid connectivity, microgrid technologies, or waste-to-heat solutions. We see it clearly that data centers are becoming the new small power plants. This is actually a great segue to hopefully the most interesting video that we prepared this year. This year we decided to do something different. And the video that you are about to watch is basically addressing the topic that we are all here for. As the AI revolution unfolds, we see incredible potential in world models and physical AI. To help you align your vision with the global demand we see every day, I've asked 2 of our top strategic minds to share their unique perspectives. First, my great friend, Dr. Munib Amin, our chief scientist and head of research. Munib oversees our critical partnerships with Stanford University, Fraunhofer Institute, Aachen University and ITS in India. Joining him is our futurist and dear colleague Thomas Boumans, who leads our trends radar and the foresight team in corporate strategy. Thomas is the one mapping the emerging opportunities and risks that shape E.ON's strategy for the coming years. I believe that this fusion of research and foresight will provide exactly the insight you need for the next 2 to 3 years. And I do hope that you will get inspired and enjoy from this session. Thank you.
Hey, Munib, good to see you.
Hey, Thomas, good to see you too. Looking forward to the discussion. But before we talk about robots, let us start with a bigger picture. Why is robotics becoming strategically relevant for the energy networks now?
Well, it's due to converging trends. I mean, energy networks are expanding, managing more renewables and higher demands. That's one thing. Then resilience got key, including fast response to any damage. And at the same time, skilled technical workforce is getting scarce. So there's more to do with higher requirements also on physical work, and there's less skilled people. It calls for a robot, I would say.
So the main driver is not fascination with robots.
The strong driver is operational necessity. But also, let's not underestimate the impact of human fascination. It makes people move. So maybe we can combine these two drivers.
How should we frame automation in that context?
I would say automation should be a companion rather than a replacement. It can take over repetitive or hazardous tasks and allows the technicians to focus on work that requires human judgment and only humans can do at this stage. However, we should not be naive. I mean, robotics and humans working together requires ethics and agreements. And we see that in AI already, and robots is basically putting AI and automation together.
And how does this connect to resilience?
Well, resilience is not only about building the infrastructure, the resilient or hopefully resilient infrastructure, but it's also how we run it. And this means we need to detect problems even earlier. We need to inspect dangerous areas safely and also respond swiftly to damages from storms or physical attacks. So yes, there's a close connection to resilience, also how we operate the networks.
Okay. Do you see a risk that public attention focuses too much on humanoid robots?
No. I mean, humanoid robots are visually powerful, and I think they will be important caring about humans, like elderly citizens. But in critical infrastructure, there's more benefits in the coming years from less spectacular systems. So lifting aids, tool transport, or safety companions. So it's not that we need to avoid the humanoid robots. They will be powerful elsewhere, but for energy networks, we need to think differently.
Yes. And now, if you had to summarize the overall trend.
Yeah, I would say Europe's energy networks are entering now a phase where the complexity, resilience requirements, and the workforce scarcity make automation a strategic imperative, and we need to prepare. Okay, so now I've been talking about trends, but of course we're interested. So what's happening in innovation? What is coming up? What's helpful for already at this stage? So where do you see robotics already useful? Where a first use case is clear from your perspective?
I guess the most credible starting point is inspection. Substations, power lines, towers, masts, and underground cables. Robots, drones, and sensor platforms can collect visual, thermal, or acoustic data and reduce the need for people to enter hazardous environments. Inspection is especially attractive because it is relatively easy to implement.
Okay, so inspection is probably the first wave. What's next?
Maintenance support, tool transport, lifting heavy loads, support during cable installation, assistance on towers, and eventually more complex manipulation tasks. But this is much harder. It is one thing to inspect a component, it is another to open a cabinet, handle a tool, manipulate a cable, or work on equipment that differs from site to site.
Well, then if you hear that open a cabinet is an issue, and at the same time you see on the internet, robots doing flips, sounds or feels like we had passed this already. So where are we actually at this point?
It is a misunderstanding that the advances in robotics is only dancing and flipping robots. Robots have made spectacular progress in locomotion, but locomotion is not the same as operational usefulness. Maintenance requires useful action. A robot must identify the right component, understand the situation, choose the right movement, apply the right force, avoid damage, and know when to stop. The real challenge is manipulation in unknown or highly variable environments.
Okay, I see. And what is then the specific challenges in the grids? What makes the grids such an interesting use case then for robotics?
Yeah, traditional industrial robots work well in factories because the environment is controlled and the task is repeatable. Electricity grids are different. They comprise equipment from several decades, different manufacturers, and different design standards. The real environment might even differ from the original documentation. That makes grid robotics difficult.
Okay, and this is probably where physical AI kicks in then?
Yes, exactly. Physical AI is about enabling machines to perceive, reason, and act in the physical world. For grid applications, a robot does not only need to see objects, it has to answer practical questions like, what am I looking at? Can I reach it? Is it safe to touch? What happens if I apply force? Do I need human supervision?
Okay, and world models that we hear about could help then?
Yes, they could potentially help. World models can help robots to predict how the physical environment may respond to their actions. That is essential for manipulation. A useful robot needs more than image recognition. It needs to anticipate the consequences of its actions.
Clear. I mean, but what does this imply then for companies? I mean, a lot is going on and things are moving as we speak, so should we wait?
No, we should not wait. But we should also not overpromise. Companies need to start building robotics competence now. Identify suitable use cases, collect field data, run pilots, understand safety requirements, train workers, and so on. The point is that the learning curve will be just long.
Okay. So what would be the right deployment philosophy then?
It should be task specific, not necessarily humanoid. Start with an operational problem. Question is the task dangerous, repetitive, inefficient, or physically demanding? Is scarce labor a bottleneck? And then ask, what is the simplest technical solution? Sometimes there may be a robot, sometimes it may be a drone, sometimes it may be remote switching, a crawler, a lifting aid, or whatever. The principle should be design a machine around the task, nothing more.
I see. And let's say looking at innovators, because this is an interplay between the operations, the companies, the innovation ecosystem. So what should innovators focus on now?
They should definitely not only focus on building more advanced robots. They should also make adoption easier, better training methods, simulation environments, safer interfaces, certification approaches, and integration in the existing operational systems. The real question is whether an energy company can trust a robot, supervise it, maintain it, and finally integrate it into our critical infrastructure.
Okay, so I mean, if we look at all of this, robotics is clearly not just a technological trend. It's basically a response to more complex infrastructure, higher resilience demands, fewer skilled workers.
Yes, exactly. The goal is obviously not a robotic spectacle. It is simply useful automation.
Yeah, then I would say the call for innovation is out. Let's see what the future brings. Excited about it. Thanks so much for the talk, Munir.
Thank you very much, Thomas.
See you.